It's looks like Take Notes Tuesday today. Um, looks like 13 questions of pure fun and enjoyment. Oh yeah. So I have two goals for today. I'm hoping I can finish the review notes and then go over the test topic. Test is a week from today, next Tuesday, the 17th, St. Patrick's Day. Just saying. Not that that has anything to do with the test. It has to do with whether or not the Talbot house will be having corned beef for dinner. That's anyway, moving on. Find tan and cosine if sine is -3/7 and cosine is greater than 0. Okay, I just want to add, this says identities right here. This is specifically the Pythagorean identity. I'm adding that word so that you can match this problem up to the test topics, because one of the test topics says Pythagorean identity. So I want you to be able to know that that's this type of problem. And the first thing I need to do is figure out the quadrant. I'm going to figure out the quadrant, draw a picture, and then do Pythagorean theorem. So I'm going to read this. It says, if sine is -3/7, so I'm going to make my little baby coordinate here. Sine is y. So it's saying y is a negative. So if y is a negative and cosine is x, and it says x is greater than 0, so x is a positive. Okay, pause there. Does that make sense? Okay, if that's the case, what quadrant am I in? What quadrant has positive then negative? 4, quadrant 4. Okay, and I'm going to draw a bow tie triangle in quadrant 4. Okay, now I'm going to label my triangle. It says y is -3/7, so that's going to go on the vertical part. The height of the triangle is y. The hypotenuse is 1, always 1 on the hypotenuse, and then x is what we're solving for. Okay, everybody okay with my triangle, the quadrant, and the labeling? Anything you want to ask before I move on? Okay. Pythagorean theorem, x squared plus -3/7 squared equals 1 squared. X squared plus 9/49 equals 1. Do you guys see where I got the 9/49 from? And also, do you see that it's positive now? X squared plus 9/49 equals 49/49. Minus 9/49 minus 9/49. Okay, now this is going to be a minute. So as I said, these problems get spicier the further we go. This one has a simplifiable square root. So over here in the space, I'm going to go 40 8 and 5, 4 and 2, 2 and 2. Circle 1, 2, cancel 1, 2. The circle 2 comes outside. And these two guys are left over, so they get multiplied and stay inside. And then the square root of 49 is 7. Okay, pause there real quick. Do you see where I got the 2 root 10 from? My twins out of jail simplified square root. Do you see where I got the 7 from? So remember, when you square root a fraction, you have to do it separately. So square root the top, square root the bottom. Okay, now last step for this, I need to choose if I want the positive or negative one. And it's X. So which one do I want in this problem? I have two options. I can look at the picture and see that it's going forward, or I can look at my little coordinate and see that it's plus. And I want the positive one. Okay. Everybody good with that so far? Notice this problem has an extra piece on it we have not done before. And I'm going to ask you to buckle your seatbelt for this part. Is your seatbelt buckled? You should make sure that you're buckled in. Okay, so we found cosine. This is what we've done so far. It's not, it's okay. Tangent adds a new step. I want to remind you that tangent is y over x. Tangent is y over x. Okay, so tan theta is going to be a fraction over a fraction. What's y in this problem? -3/7. And what's x in this problem? Okay. Now, the 7s cancel. You can show the keep, change, flip, but you don't need to. You can cancel the 7s. These denominators should cancel every single time. If you don't have that, you did something wrong in the problem. So no big deal. That's not where the spicy bit comes from that I was mentioning. Do you see where the spicy bit is? Do you have the cartoon bubble of your math 2 teacher over your head right now? And what are they saying? You can't leave a root in the bottom. They're saying it just like that with that voice too, just so you know. It's not like their normal voice. It's like the made up Peanuts teacher voice. Okay, what do I do to get rid of the root on the bottom? Yep. Okay, now the thing is you only need to do the root part. You don't need to do the 2. Okay. The top is easy. It's 3 root 10. What is the bottom? What's 2 times root 10 times root 10? 20. Okay, and if you want to, you can put these little notes over here just in case you want them. It's 2 root 100, which is 2 times 10, which is 20. Mrs. Talbot, did it just take you like 10 minutes to do one problem? Yes, but I promise you, they're not all going to be like this. I'm just going to let that sit for a minute just in case anybody needs to. What happened to my 0? I think that's about as spicy as that problem could get, honestly. That's about worst case scenario. Okay, number 2, convert each degree measure to radians and each radian measure to degrees. Dot line. Pi's on the top. Gonna put pi on the bottom to cancel. 180. Cancel the pi's. And I'm also going to reduce this bit. 9 goes into 180 how many times? 20. I think one of the quiz versions had that exact problem. Did anyone have that one? I don't remember. It's been a minute. Okay, number 3, times line, degrees on the top, degrees on the bottom, pi on the top. Okay, first thing I'm going to do is reduce by a factor of 10 by canceling out the zeros. And then I say to myself, oh, those are both divisible by 3. Negative 7 pi over 6. Any questions on number 2 or 3 before I move on? I like those. Okay. Scoot your paper down to 4 through 7. And these are basically the warm-ups that we've been doing the last week or so. And what I like to do is kind of ignore the direction. This is going negative 3 pi over 4. We don't really care about that. What I care about is when I look at this, do I see a 45, 45, 90 or a 30, 60, 90? That's really the only question you need to ask yourself. This one has a denominator of 4. It's going straight through the quadrant middle, and the legs look equal. Which one is it? 45, 45, 90. Right. Okay. But what I do is I go, okay, this is 1. This is root 2 over 2. This is root 2 over 2. And then I think to myself, I'm in quadrant 3, so they're both negative. Are you guys good with that? Okay. And then I say to myself, cosine is x. So that's this one. So the answer is negative root 2 over 2. Okay, so 3 steps. Draw the triangle, figure out which one it is. No. Draw the triangle, worry about the signs, and then figure out which one it is. Okay, so number 5. Draw the triangle. $30, $60, $90 or $45, $45, $90. $30, $60, $90. You can tell because there's one short and one long, and it's not like a square cut down the middle. It's like a equilateral cut down the middle. 1/2 √3/2. Okay, so that's step one. Draw, label the triangle. Step two is worry about the signs. This is quadrant 2, so negative x doesn't really matter because it asked for sign anyway, which is the y, which is this. √3/2. Okay. The next two are a little bit of weird situations. You've got a tan, and you've got one that won't make a triangle. Okay. $30, $60, $90 or $45, $45, $90. $30, $60, $90. 1/2 √3/2. Quadrant 2, so the x is negative. Okay, and then I'm going to remind you tangent is y/x. So 1/2 over negative √3/2. Okay, now do you notice the 2's cancel? They should cancel every time. Do you see the 2's? Everybody see the 2's? Okay, 2's cancel. Oh no. Math 2 teacher shows up. You can't leave a root on the bottom. Okay, now what the heck do I do with this? I can't make a triangle. It's pointing directly onto the axis, but I'm reminding you we're working on the unit circle. So this coordinate right here is 0, -1. Do you remember the coordinates that we put on the 4 axes on our unit circle? Okay, so sine is y. Y is -1. That's how you do it when it's right on the axis. You figure out the coordinate, and then you figure out which one. Or if it's tangent, divide. All right, everybody, we have finished page 1. Woo! Graph each function using radians. Will be. Okay, so I'm going to go down the side and go A equals B equals P equals H equals K equals. Okay, here we go. What is A? 3. What is B? 1. And you can put a little 1 there if you feel like it. Period is a formula 2 pi divided by B. How many boxes is 2 pi on this paper? 8. Okay, now here's the big question. Is the 1 the H or the K? Okay, great job. There's no parentheses, so H is 0. All right, so K equals 1. I'm going to put my midline in. And then amplitude 3 on either side of that. Okay, this is cosine. The locator point for cosine is H comma K plus A. So H comma K plus A. Is up there and circle. Period is 2 pi, which is 8 boxes away. So it ends right there. And positive cosine goes from the top to the top. So it's going to be at the bottom in the middle, midline, midline. I'm just going to leave this one cycle of the wave on my picture right now for notes purposes so you can see exactly where it stopped, where it ended, where it started, where it ended, the height, whatnot. I'm pretty sure on your test, though, it says graph as many cycles as you can fit. So you have to like keep going on your test. But for this, I really want you to see the shape. So I'm leaving it. Okay, number 9. A equals B equals P equals H equals K equals. A is -3. B is 2. Period is 2 pi divided by B, which is pi, which is 4 boxes. H is positive pi over 2. K is -2. Ooh, a whole shebang problem. Okay, start with the midline. -2. Amplitude is -3. Don't let that bother you. Just go 3 on either side. Okay, locator point for our sine is just HK. Pi over 2, comma, -2. Graph and circle. Period is pi, which is 4 boxes away. So count 4 boxes away from your start. 1, 2, 3, 4. That's your end. Okay, now this is the moment. If I was going to be in high school again and do this problem, this is where I would screw it up. I just have to tell you that I would forget that sine was negative and I would start going uphill. I can just totally see myself making that mistake. But sine is negative in this problem. So you have to go down first and then up. I'm going to leave it like that so you can clearly see the shape of negative sine. How many of you feel like you might forget about sine being negative and going downhill first? 2 people are willing to admit that they do the same mistake as me. Well, Mrs. Talbot. I'm also the person, I didn't get to have you guys for this chapter, but I would always forget to dash my like not equal to inequality lines, like you have to make it dashed or solid. And then I'd have to go back and like eraser mark in the dash. Oh, it looks so bad. It's fine. It's fine. It's fine. It's good. We have our weaknesses, right? Okay. Now let's go down to number 10. And I'm going to cheat on number 10. Never mind. Never mind my cheating. It's not happening. You see nothing. You don't see anything. You see nothing happening here. Just totally drawing a really great circle by myself without any tools or instruments or anything. Just cheating away. No, that's what I get. That's what I get for cheating. The ruler moved. If only I could be like Hermione and like pause time and then make my circle and then come back and be like, woo. Oh, I guess if I was Hermione, I could just have some kind of spell to make a circle on my paper. Yeah. I don't know. Okay, so 0, 6 pies over 6, 12 pies over 6. And I know 11 pies over 6 is going to be right before 12 pies over 6. Okay, before I move on, I want to make sure that this makes sense. Everybody okay with I know it's not perfect location of 11 pi over 6, but you get the idea. Okay, it didn't even ask me to sketch it. I actually could do this whole problem without sketching it, but I just feel like I don't know. I feel like it really helps. Okay, so I graphed it. It didn't say to graph it, but I did. It says find the reference angle. The reference angle, because I'm in the fourth quadrant, I want to find the difference between 12 pi over 6 and 11 pi over 6. Which is pi over 6. You don't need to show this work. If you guys know 12 minus 11 is 1, we're good. We're good. Okay, now it says find the angles in the other three quadrants. We haven't done a lot of this, so this is going to be great practice for us. I think you can totally do it, but why not practice it again, especially in radians? Okay, now there's really no reason to show my work, but I'm still gonna do it for quadrant 2 and 3, just to kind of remind you in case your numbers aren't this nice. So quadrant 1 is always the same as the reference angle. This would be 1 pi over 6, just pi over 6. The reference angle and quadrant 1 should always match each other. Quadrant 2 is 180 minus. 180 in this problem is 6 pi over 6. So 6 pi over 6 minus pi over 6 is 5 pi over 6. But I'm pretty sure that you could have figured out that was 5 pi over 6 just in your head, just from the graph itself. Quadrant 3 is 180 plus 6 pi over 6 plus pi over 6 is 7 pi over 6. Again, I figure you could have figured that out, that it's 7, but that's okay. Just wanted to remind you about the 180 minus and the 180 plus. Okay, now coterminal. We haven't done this in a minute. Coterminal means it's in the same spot as your original angle. You add 360 and minus 360. What number do I have written up here that is equivalent to 360? 12 pi over 6, right? Okay, so 11 pi over 6 plus 12 pi over 6 is 23 pi over 6. And then minus 360 and that should make sense if you think about it, going backwards, pi over 6. One of the things about the test that I will tell you is it says all answers should be in original units, which means that if you answer this question in degrees, it will be wrong. I actually think the math is easier in radians because you're doing like 12 minus 11. Okay, how many more? 3? And they're all polynomials. Oh, your fave. Okay, number 11. Factor each completely and find all zeros. 1 0 has been given. Do you notice that there is a GCF in this problem? Do you notice now that I said something? No? I hope there's a GCF because I'm lazy. Okay, and then what do we do with fractions, guys? So x minus 1/5 will become 5x minus 1. Just much easier to divide by. Okay, so what size box? 3 by 2. It's coming back to you. That's to be 25, huh? $40? That can't be 40. Yes, it can. I forgot my times tables. I think it's because I was kind of hoping that that was going to factor, and it doesn't. Okay, so I have my x. I have my 5x minus 1 from the side, and x squared plus 5x plus 8, unfortunately, from the top. So that's factored. That's as factored as that can get. Do you guys all know that box and diamond will not work for 8 and 5? You could give it a go off to the side, but it's not going to work. So this is factored form. That's done. So you go x equals 0, x equals positive 1/5. I got that from the original problem also. There's that. X equals negative b plus or minus square root b squared minus 4ac all over 2a. It's going to be imaginary, isn't it? Okay. X equals negative 5 plus or minus 25 minus 32. I got I root 7. You guys get I root 7? Okay. So we have 2 single real roots and 2 single complex roots. How many more problems do we have? Dos más. Bilingual. Completely. No. I know the word calculadora. I know lapis. What else could I possibly need? What's protractor? Isn't it something like protractor? Pretty sure protractor is like protractor. Okay. Number 12. Write a polynomial function in factored form. Woohoo! That has the given zeros through the given point. I like factored form. Okay, so I have y equals a 2x minus 5 squared x minus what? Okay, pause there. Does the 2x minus 5 squared make sense? Are you sure? Okay. 5,346, that's a very specific number. Okay, so this is 14 minus 5, which is 9. 9 squared is 81 times 6, which is 486. Please tell me it's decent. Ooh, 11. Hey, I thought that one was going to be really bad, but it wasn't that bad. I'm pleasantly surprised. Okay, last one. Standard form with an I. What do I do when I have one root that has an I in it? What do I do? What do I do? I need to remember something. The conjugate, right? His buddy. Okay, so y equals, and this one does not have a point, so we don't need to solve for a, which is great. But we need to remember the switch sign. So x, switch the sign, switch the sign, x, switch the sign, switch the sign. X squared, negative x, positive 1. Okay, this is negative 9i squared. Negative 9i squared is positive 9. Y equals x squared minus 2x plus 10. Okay, So if you're looking at the front, what is the homework review assignment? When is the review assignment due? Friday? Does it look like it's 2 nights worth? Okay. Um, last thing I want to do is talk about the test topics. Which are definitely on my screen. They're not, that's the stats test topics. Look at that list. Okay. Test topics. Next test is Tuesday, a week from today. You can use a note card and a calculator. Yay. Hey, I just made a rhyme. You try to. Okay. Given the graph of a trig function, so that's a sine or cosine wave, choose the correct equation. Multiple choice. You have a wave, pick the right equation. Okay. Setting an angle in standard positions, finding the reference angle, the angles in the other quadrants with that reference angle, and coterminal angles, the original angle in radians. Do you know what that means? We just did one. It was the one with 11 pi over 6. What number was that? Number 10? Was number 10. Graph a trigonometric function. Trigonometric function is a sine or cosine wave. Identify A, B, B, H, K, the locator point, and graph. Pythagorean identity. You know what that is? A squared plus B squared equals C squared, the right quadrant, all that. Factoring a polynomial completely, then finding and describing all roots. That was number 11 that we just did. Finding the standard form of a polynomial given irrational or complex roots at a point. And that's kind of a combination of the last two, because you have irrational or complex, and then you have to solve for A. Do you know what all those things are? Are any of those things a giant surprise? I hope. I hope not. No. There's examples of all of that in your review assignment, which is great news. And that's it. So you guys can work the last bit, start the review assignment, whatever you need to do.